So hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with another great project which is I have simulated in the MATLAB Simulink. So let's get started without wasting any microsecond. So you can see here I have developed the active harmonic filter, and if you are following my YouTube channel then you are aware about it that I have already uploaded lots of video regarding related to the harmonic filter, specifically passive harmonic filter. We have designed all the four type of passive harmonic filter in this video. If you want to watch this video, you can watch through the link that is given in the description box, and I am suggesting that first go through this video, so that's why you will understand what is harmonic, how to mitigate the harmonics, and all the things related to the harmonics very clearly. Okay, so this is the second part, or this is the advanced video related to the harmonic filter, because at this stage we are at active harmonic. What is the active harmonic filter? What is a passive harmonic filter? So what is a passive harmonic filter? Basically that passive harmonic filter is used to mitigate a particular harmonic, let's say third harmonic, let's say fifth harmonic, let's say seventh harmonic. So passive harmonic filter targeting one particular harmonic, that is active harmonic filter, is remove all the harmonics irrespective of that order. So that only possible through this complex logic, and that used to firing this inverter, and this is what we are going to see here in this video. Okay, so let's jump to the simulation part. Back to the simulation part, and you can see this is a simulation that I have done in the method. This is the grid that we have considered, and this is the non-linear load which generate the harmonics, and we can see the voltage and current through this RMS block, and this is at the source side and this is at the load side, and this is the scope. Over there we can check how the waveforms are there. This is the part which is used to inject the reactive power, or whatever can say, like a in the power that reduce the harmonics through this inverter part, and this inverter control through this controller and this SPWM inverter technique. Okay, so let's first run the simulation so you will understand all the thing very clearly. I have just started the simulation. This breaker is off, it means that this part is isolated, so whatever the uh, current is taken by the load, that clearly reflected over here. And if you want, you can check the waveforms also. If you want, you can check waveform by just double click on this scope, and yes, this is the scope one. You can see this is the waveform that we are getting right now, and you can see it is a voltage is sine wave, but the current is totally not sine wave, and that cause the reflection over the source side, and which eventually malicious the source supply, and that's what the harmonics are. And what is the purpose of harmonics? What is the purpose of harmonic filter? To filter out this current, to filter out this waveform, and make it very clear sine wave like this voltage. Okay, so if you want to do the FFT analysis, what level of harmonics that this load are right now generating, you can check by just double clicking on this power GUI block. Go to apps, go to FFT analyzer, just click over there and wait for some time. As you are know that we are getting the malicious waveform for the voltage, so let's not for of the voltage, for the current. So let's consider here the current. Let's say start time from 0.1. We want to check from this, so we can initially there is spikes because of the non-linear load, and the system, the current takes some time to stabilize. So let's say what is the numbers of cycle that we want. Let's say 5 cycles are there, so we can check exact values. And then which was the frequency is a 50 hertz, because we are working over the 50 hertz right now, and let's say we wanted to check the harmonic order. So for that, what you have to do right now, you have to place on the compute FFT, and eventually we can check. This is the FFT that we are getting 22.90 percentage. This is a percentage that is generated by the this is a 22% harmonic level generated by the load. You can see fifth harmonic is dominated, which is nearly 14, above 14 percentage. Then seventh harmonic is also there, then 11th is also there, then 13 is also there, then 17, then 19 is also there. So there is a malicious waveform, totally malicious waveform is there, and we need to clear out through this active harmonic filter. Okay, so for that what we have to do, we have to just turning on this switch and run the model again. So as you are right now aware about it, this that we are getting 22% harmonics, and for the voltage we are getting, let's say, 0% harmonics, because there is nothing harmonic in the voltage. You can say there is a 0% harmonic. Okay, so yes, right now I will just turning on this switch, which eventually make this filter picture inside the simulation. Okay, and how it is working, just double click over this controller. You can see it's taking some feedback, load current, then the grid voltage, then we can say this is the capacitor or the capacitor filter, harmonic filter inputs, and then it is going to this converters, like we are going to convert the three-phase waveform on the DQ axis, and then which help us to finally trigger this uh, MOSFETs, and that's for that we have use this simple technique in which we have the signal generator, which is compared with the waveforms and then finally generate the output, and that output control these MOSFETs. Okay, and yes, I just run the simulation again and we'll check the waveforms also, like that how the waveforms that we are getting from earlier and right now. Okay, so without filter we are getting like a spikes type waveform, but right now what we are getting, we need to wait for some time to stabilize the system, because it is a non-linear load, like a capacitor, like an inductor, and like a switching device, which initially capacitor initially work as a short circuit, whereas inductor work as open circuit. So it takes some time to stabilize the circuit. And if you want to check this waveform, you can just double click over there. Initially we are getting a spikes type waveform, but right now I can say it is not a spikes type waveform. It is a clearly sine wave, but it is a reducing because of the this component. It takes some time to stabilize. Once it is stabilized, we are getting final. Okay, so yes, let's wait slide more time and we'll get the exact waveform. So at this stage, you can see here we have already simulated the simulation for nearly 20%. And if you want to check, you can check waveforms also. Waveforms are also stabilized. And yes, at this stage, current is very clear. So I have to stop the simulation. As I stop the simulation, we need to do the FFT analysis again. At this stage we need to do the FFT analysis again, so we can check exactly what we are getting from there. So I have just started the FFT analysis, and it takes some time to exactly the waveform that we are getting, and we need to check at the very last stage, let's say 0.45. Start time we have considered 0.45 from here, so we will get the exact waveform after the stabilize. Let's say frequency is a 50, and let's say numbers of cycle, let's say 1. Is it possible to 2? No, it is not possible. So yes, we need to consider the one cycle and do the FFT analysis, and we are getting the harmonic order, which is nearly 2.64, which is clearly means that earlier we are getting 22%, right now we are getting 2.64%. So let's say we have to check from 0.4 like this cycle, and let's say 4 numbers of cycles. So yes, and if we do the FFT analysis, which is again we can say what is the waveform. Okay, it is a 4.24%, which is under the limit of the current is 8%, whereas for the voltage it is a 5%, because we are getting the current harmonic, which is a 4.24%, which is lower than the limit that is designed by the IEEE system. And at this condition for the voltage, we are getting the zero, I can say zero harmonic. So this is how you can uh, create the active harmonic filter, and you can see it is working very clearly. If you want this file, it is available in the description box. For any type of MATLAB related project or any type of electrical or electronics related project, you can connect with me through my email ID or through my WhatsApp number that is given in the description box. So thank you very much for watching this video. If you have still any queries, just comment it, I will definitely reply. Thank you very much for watching this video.